Okay, so we will continue to this is about the equations of lines and lanes. So let's first recall what you know or recap what you know in R2. I think, if we are in R2 like this is X, Y axis, this is Y axis. If we have a plane like this, traditionally, or we write a Y as Kx plus B, this K is called slope, right? I think everyone knows this, right? And B is the intercept on Y, like this. This is the slope. And also, we can change our perspective right in another way. So you can say, if this is K, and then we can say, okay, you can say this is the direction of the vector. And also, we know this is theta, right? We know tangent theta is K. You may say, I don't know this, but if you know this, you have to check what you studied before, or just, memorize what I told you here is K. And then we can say, okay, by the definition of tangent, okay, so we know there is a right triangle. The tangent, you can think in this way. So you can present this is K, this is 1, right? And then there should be a direction, right? And then we get a, why still? Okay, we can get a direction, which is 1K. So you may say, why do you have to write 1K? You can say 2K. It's the same. I just write the either is the 1, This direction is called the direction of the line, right? Where this vector is called the direction vector of the line air. I think the students are in general are more familiar with this because I think in Calc 2 you already started this. Maybe in that test in your high school you already knew this. Okay, yeah, direction. This is called the direction vector. And then if we know this, we can write our equation for the, I think this is called the scalar equation, right? Before we can write the equation in other format. So we can say, okay, if this is the, okay, let me redraw a picture. Okay, the same one, let me redraw. So this is our line. The equation is y equals to kx plus b. We get the vector v. The direction vector is 1k. Okay, or in general, you just write a, b in general case. And then, okay, we pick any point, x1, y1. Okay, we write is r naught. And then how do we write the equation? Yeah, the vector form. Okay, so you can, this is v, right? And then you can say this vector, the line is kind of, if we have v, and then tv is kind of, you are violate the vector, right? When t is 1, that's v, 2v. If this is v, 2v just go more, 3v go more, right? 4v go more. Negative v, you change the direction. Negative 5, you change the direction. And double the length, like that. You get this kind of, this is a vector, but for vector, it's kind of in this place, right? Because when t is 0, you get a 0 vector. So this is a vector. But this line passing to this point. So we get gamma t is gamma 0 plus t v, because when you can say when t is 0, it's just gamma 0. When t is changed, for example, when t is 0, you get this. So when t, for example, when t is 1, you get, if this is v, you get t, this is tv. Okay, this is v, and then this is this. And you can say gamma 0 plus tv is this vector, right? This vector is just this point, right? So means that when t is changed, when t changes, gamma t stands for a point, stands the point on the line. Is it clear? This is called the vector equation of a line in R2. Hope it works. Okay. So in general, just like formula, if we have a line passing through one point, gamma 0 is x naught, y naught, with the direction vector v. Okay, maybe you write it like this: a, b, and then the vector equation of line is gamma t, where you write RT is the same, okay, is R. I just use R, it's the same, okay. R plus T V T is R. It's a scalar, okay. Scalar, just emphasize it. Maybe I should emphasize, I write a remark here. Probably you know. Okay, let me write a remark. It's kind of some notation. So vector and points are the same in math. How do you understand it? Okay, for example, even in R3, let me draw a picture. Okay, sorry. For example, you have vector v where you have a point. So you have a vector. In general, you have if you are talking about a vector, you have an arrow, you have an initial point, and you have a terminal point, right? But when you are talking about a point, only has a point. But we can always think a point as a vector. How? If we have a point, we can always connect this point with the origin, and automatically you produce a vector. And then if you have a vector, you can, we always think about the starting point at 0, and then you can think the terminal point as the point. In this perspective, vector, I can say vector is equal to points. Is it clear? A vector, it's kind of a perspective. It's not kind of there the same, but you have to use some language to connect them. But you can understand it in this way. Okay, I hope so. I hope it's clear for you. Okay. Okay. So this is kind of what we record. You know this part. If you don't know this part, I think I already stated it clearly. You just follow my method and listen to the recording. So, and then this back to R3. Actually, in R3, the whole process is the same. So in R3, you don't have this. You don't have kind of this kind of scalar equation. I don't think so. I don't think we don't have this because we have three coordinates. How do you do that? I don't know, sorry. So let's come to R3. So in R3, we generalize the the vector equation for the line. Still we have a line. We just we have this is X or probably so this is X, this is Y, this is Z. So let me first draw a line. Okay, here a line. So this is a line. Okay. Oh, it's a problem. Because I have some accent. The problem line. I'm from southwest of China. I cannot pronounce this sometimes, even in Chinese. Line. Okay, now it's right. So we have a line. How do we write this equation for this line? So first, you have to know some information. So first, I say, okay, the line pass a point. Now it's in R3. R0 is X naught, Y naught, Z naught. And we have the direction vector. V is A, B, C. And then how to write the equation? Okay, let's find this is gamma. Okay, so this is, okay, this is, sorry, gamma 0, and this is V. Okay, the direction of V. How to write the equation? You can say, okay, this is 0. You can always get a vector like this. And then this is V. If we have TV, for example, TV, not television, okay. If we have TV, for example, this is TV, right? For example, if this is T, the direction. This is TV. And then you can say this vector plus this vector. Let me change the color. Okay, this vector plus this vector, you always get this vector, right? If T is changed, you play the same game, right? You get all the points on the plane. By this, we can define this gamma T, or also formula is gamma 0. No, R, sorry, because I like the gamma, because I use a lot of like Greek letter, plus T, V, T is a parameter, or P is the parameter. We call it a parameter, or it's a scalar number. From a number, this is scalar, we call it a parameter. We call it a parameter. This is called the vector equation of a line passing through this point with the direction vector this. Okay, let me cross it. No, let me type them all. So we still have time. Okay. So this is the vector equation of error in R3. Okay, in R3. You can say, if you understand this, automatically you can generalize in R4, R3 like that. Anyway, okay, like one thing I want to emphasize, in math course, we only teach you R3. Nobody will teach you how to do any problem in R4, R5. If you study economy only, you may know sometimes the variables are, are many, right? It's automatic you get like 5 variables and you have to put it in R3, or in other magic is similar. I think if you study food science, you have to use, some factors, that's a variables in math. Okay, you have to, after we study 3 dimension, you have to automatically know how to generalize all the information to R3. because from R2 to R3, in general, there's some gap. For example, you can in R2, we have this kind of stuff, right? But in R3, we don't have that. If you say you may have right one for you, okay, but I don't know. Okay, so let's continue. Okay, so for the vector form, we can do more. So let's write it out. Let's analyze it. Okay, sorry. For RT, this is R lot plus TV. T is parameter. And then we write it outside because RT is just XT, YT, ZT, right? This is a vector. This is, okay, let me change the way because you may not familiar with this. So this is XT, YT, ZT equals to, they are the same. So this is X naught, Y naught, Z naught plus T, A, B, C. Let's do the math. X naught plus T, A, Y naught plus B, Y 0. Oh, what am I writing? Sorry. What happened? Plus TB, Z lot plus TC. So we get XT is XT plus TA. YT is Y naught plus TB. Yes, right. ZT is Z naught plus TC. Right? We get a new format. If you look at this, probably you say, okay, this is more direct. Yes, because I also like this because it's more explicit. So, and then we call this a lame parameter equation. So this is called the, no, vector equation. Or you can say vector format. Anyway, the book just called this in this way. I have to follow it. Okay, this is called the parameter equation. When you are doing a problem, you have to emphasize, okay, this is a parameter because sometimes you may make a mistake. Okay. So, and also we can go more. So we can go more because there are many formats. How do we go more? So first, let's go more. So we can continue to change this part. We continue to change this. Okay. Continue to change star. Okay, just use star. How? We write xt minus x naught is ta, yt minus y0 is tb, zt minus z0 is tc. You say, ask me, why do you write a t? Because I want to emphasize there is a parameter t, but you may say, if I don't write it, I'm wrong. No, you are not wrong. So just emphasize. Okay, let me change it. So you don't have to write the t, but I just write it for the clear. I will emphasize it. Okay, the same for this place. And then we can write this, you know, and x. No, I will come back to the color. X minus x naught over a is t. Y minus y naught over b is t. Z minus z naught of c is t. Of course, ABC cannot be 0. You may ask me, okay, if ABC is 0, what happened? Okay, let me talk about ABC are not 0 first. Okay, by this, we can get a 3 equation together. X minus x naught over a plus y minus y naught is c. No, z minus z naught is, no, what I'm doing. See, this, we get a new formula of this equation. So this is called the symmetric equation. So it's kind of now we get a straight kind of equation for a line. So the first one, the second one, and the third one, right? So this is for A, B, C are not zero. A, B, C are all not zero. Or you can write A, B, C is not zero. That they are same, right? You know, sometimes just some three. Okay, so we have three equations. Okay, for a line, we have three kind of equations to describe the line. The first one is the vector format. The second one is the parameter format. The third one is the symmetrical format, or we call it the parameter equation, vector equation, symmetrical equation. Okay, but you may ask me, okay, if I, for example, I just show you, for example, now, for this equation, okay, you can say what happened. If A is zero, so if A is zero, what you get? X minus X naught is zero, right? Y minus Y zero is, okay, B is not zero, C is not zero, otherwise they are the same. Okay, is TB and Z is Z0 is TC. By this, you can say, okay, X just doesn't move. Okay, and you can say Y minus Y naught over B is T, Y Z minus Z naught over C is T. And finally, you get like this. X is fixed. Y is Y naught over B equal to Z minus Z naught. Right? Just for a special case, you might say, what about if A, B are zero? Means that A, B will the same method. If A, B is zero, this is zero, you cannot divide this part, just keep it. Anyway, for this part, you know, you have to be careful when you are doing problems, right? But you know, sometimes nobody knows. You know, if you say, okay, why didn't you give it a formula? Because there are 6 word line and like, nobody tests you about this part, right? That's what I want to say. You know, but you know, anyway, I think nobody will do math research. You know, for do math research, you know, it's kind of a lorry. We have to consider 100 cases and try to get the answer. Okay, so I think this is about the equation of the line. We have 3 format. Okay, and then let me check. We have 3 formula. You have to know 3 formula. I think logically it's very clear. I hope you can get what I say. Okay, so let's come to examples. Okay. So let's look at the examples. So the first example is find a vector equation. Okay, for this problem, okay, we have a line. So, oh, sorry, forget to change the color. We have a line passing through 5, 1, 3, a point or not, and parallel to 1, 4, 2. So you may say, okay, you never tell me what's parallel, right? You know, for example, we have a line. This is a vector. Okay, the question is how to find the 3 types of equation for the line. So let me explain it more. So we have a line like this. It passes through R lot, but it doesn't give you a language like what's the direction. That's the direction vector. It says okay. It says this is parallel to a vector v. It means that the direction vector is v, right? Just a language, you know, maybe in probably I think you should know in your plane geometry middle school. So, and then it's kind of, this problem is quite clear. We get a point, we get a direction vector, and then let's try the process. So the first is the vector equation, which is R is 5, 1, 3 plus T 1, 4, -2. So you write it in 5 plus T, 1 plus 4T, 3 minus 2T. So first one, third one, no, why do I say third? This is second. Okay. Parameter equation. So the parameter equation, you can just memorize it or just write it outside. X is 5 plus T, Y is 1 plus 4T, Z is 3 minus 2T. So this is a parameter, okay? The third one is X minus 5, 1. This is the direction. And Y minus 1, 4 plus Z minus 3, -2. I think the symmetric one is the easiest one. Anyway, I think it's the same anyway. Because this is the numerator. If you put a numerator together, you get what? If you put the numerator together, you get a vector. No, you get the direction vector. You know, the number in the numerator is the point the line will pass. Okay, this is for our first example. So I think this is the easiest one. So let's go more. Let me solve it. So we still have time. Anyway, that's fine. We still have 20 minutes. Because this part is quite simple, right? Because in Friday, I will help you to deal with some homework. And also you can, I will ask some of you do the presentation, just show me some problem or your homework you do. Or, okay, one more. If you want to me present some problem in the class or on Friday, every Friday, you just send me the problem before Friday. Okay, at night of the Thursday. Okay, but you cannot just ask me to show all the problem because we don't have enough time. Okay, just, you know, I think I don't know this kind of problem. Can you show me something? Okay. Or in general, if I have time, I will do a summary after 1 week or 2 weeks. Okay. Hope you to understand it. So example 2. So find the parameter equation and symmetry equation for the line. Find the equation for the line with what information? Passing through 2 points. The first point is 2, 3, -3. B is 3, -1, 1. So it's kind of, we have A, we have B, and there is a line passes through AB. Find the equation. 3 types of equation. If you can't find one automatically, you can find all. So if we do this problem like what I said, like what we studied, you have to know what? So you have to know first a point. There are 2 points, right? Of course, you can pick any one. You may say, which one do I pick? By your preference. Okay, for example, I find a point. For example, I will pick A. You might take a B. Okay, no rule. Second one, you find the direction vector. How? We have A, we have 2 points. Automatically, you can get a vector field. You may say, you don't know this before, but anyway, this is new subject. In the future, you think this way, you will find you get used to this method. It's kind of trick. And then we have A, B, which is 1, -5, no. +4. So after we get this first, okay, the vector equation should be R is 2, 4, -3 plus T, 1, -5, 4, T is R. The parameter equation X, Y, Z is 2 plus T, 4, -3 plus, no, minus 5T, minus 5T plus 40. And the symmetric equation X minus 2, 1, Y minus 4, -5, no, Z plus 3 over 4. That's 3 equations. 3 types of the equation for the same line. Here. So this is about the line properties. We still have time. We'll continue. Really? Don't be hurry because you have more time. Okay. It's okay. Just give me some feedback. Do you think it's fast? Do you think it is faster for you guys? So just, I think, speed is okay. Can you? If you think it's fast, give me F. If you give me it's slow, give me S. Or if it's okay, just pretend okay. Hi guys, I need your feedback. If it's fast, give me F. Okay. How about the others? Okay. No reaction? No. Okay. Since nobody give me, no feedback, I just continue. Why? What are you doing, guys? It's so hard to type something. Okay. So